Okay, so we're talking about databases. And the thing about databases is, well, so for today we're going to just sort of say what are relational databases. The fact that there's a modifier called relational means that there's some other kind of databases, and there are. They're in fact object-oriented databases. They're databases based on XML. Um, and the thing about modern relational databases is that they all they all understand something called the structured query language, or SQL. Um, Since this is a Java class, we will be using something called Java Database Connectivity, or JDBC. And the book talks about, the book uses as its example something called MySQL, which is actually, I've used that. It's a really very powerful open source database. Um, Really, the Lamborghini of databases is Oracle, of course. And so if you're talking sort of huge amounts of data, then that's kind of where to go. MySQL is, scales up wonderfully up to a certain point, but it doesn't go quite as far as Oracle. In fact, Oracle um, actually bought MySQL, so I know it was kind of a weird thing. Um, well, for example, like in the NavSup projects that I work with, the data that goes into the simulations and the models that I use come from Oracle databases that they maintain. So they basically put and only their minions have access to that. But what they do is they'll issue queries, create these other databases, and I'll use those. And in fact, for for one of the well, for several of the projects, I'm actually using SQLite. So again, this is I'm teaching you about SQLite. That's something that I use. I found it to be really valuable. One of their other models uses a Microsoft product called Access, um, which is well, I try to not use. We've been trying for a couple of years to convince them to switch to something else because it's got lots of issues. But nevertheless, it's not bad, but it has some other things. So SQLite is just pretty remarkable because it's very small, it's lightweight, and it actually it's used in like tiny micro devices and things like that. So, okay, so persistent data, you want to use databases. Now one of the reasons for using a server-based database is kind of the same idea of using something like GitLab to hold your code. So if you, I don't know, if you drop your laptop in the toilet or something like that, and all your projects are kind of on there, if you have been using GitLab, then you haven't lost anything because when you get your new computer, you just simply pull it down from there and you're all done. So that's one of the reasons why server-based databases are useful for that. However, for local things, that's a bit heavyweight. Um, so I think today we'll probably, get to actually connecting to it because there's a little bit of machinery in NetBeans we need to understand. And then kind of how to connect to it and then how to start interacting with it. So, as you may have noticed, that the data in a program doesn't last beyond its run. So, like, for example, in that movies program, you kind of ran the program, you kind of read the data from that flat file that they had, but any manipulation that you did was lost once the program ended. So the thing is that now that flat file, that movies tab separated file is sort of like a database. But if you the way that the IMDb has actually organized it is sort of database-y in that they have a number of different flat files that have different information. So, and they've actually modified that over the years. So it used to be, for example, in the file that you processed, they would have information about the lead actor and the director and stuff like that. And what they've done is they've kind of pulled that into a separate flat file that has information about the different people, and that's in a different one. And that is how you would do it in a database. In other words, you would have, because of the relationship between these things. So think about a movie. So you have movie, you have like, let's say movie and directors. So one movie will typically have one director. I can't think of an example where they've had more than one, but if they have, it's probably been a disaster. But a director is typically going to have more than one movie. So that's the one-to-many relationship. And so now they put these in flat files because that's the lowest common denominator. But really, I suspect behind the scenes they have a database, and I wouldn't be surprised if it was actually a MySQL one. But so if you're doing server-side stuff, MySQL is the way to go, and that's what the book talks about. But that's a little bit heavyweight. What I found is that this SQLite is actually much easier to work with if all you're doing is writing applications. So a relational database, there was this guy, E.F. Codd, back in, that was freaking 50 years ago. Jeez. Anyway. But his ideas were actually kind of codified a lot of things, and that's the way a lot of data is these days. They've, like a lot of things, there are some somewhat better ways of doing certain tasks, but relational databases are sort of the standard now. So the idea is that the data is organized as a collection of tables, and each table, you should have a good thought of a table. Think of a spreadsheet. A spreadsheet, each sheet is like a table, literally a table. So what is the characteristics of a table is that it has a certain fixed number of columns and a fixed number of rows. Now the thing is that if you have and spreadsheets have sort of gotten a little bit fancier with this, but typically if you have a bunch of sheets, they're all kind of, their relationship to each other is kind of a little wonky. And what can go into a sheet isn't necessarily just tabular data. In other words, you can put all kinds of other crap in these things. But in a database, though, you have these tables are very strict. They are like arrays. There's a fixed number of columns and a variable number of rows. So it's maybe more like an array list in certain ways. But the key, why relational? It's the relationship with other tables. And the book has, what was it in the book, or was it somewhere else? Kind of why worry about this? Get back to that in a second. Okay, so the tables are rectangular data, and columns are sometimes called attributes, and rows sometimes called records. And the idea is that each row has a unique key, which is called the primary key. So it's like if you want to access a row, then you want to be able to uniquely identify it. So the relationship with other tables, the one-to-one, so it's like that's one. The one-to-many is one of the powerful ones, like director to movie. So a movie has one director, but a director has more than one movie, and likewise with actors. And the IMDb even has stuff about crews and other sorts of things. Now there's the other thing is the many-to-many relationship, and actually SQL or a standard database that doesn't usually directly support that, but it kind of indirectly does. So typically, in order to implement the many-to-many, you have kind of an intermediate table that is kind of a little gateway to all that. So, I mean, here's another example, and this is from the book. So this is hearkening back to their idea of a course and a module. Each course has a number of different modules, but each module only belongs to one course. So the way that is could be represented, and these are all design decisions, you know, but this is kind of a reasonable one, is that this would be the primary key for the course. Each module would have its own primary key, you know, each course would have sort of the name of all these different things. But interestingly, in and of itself, it doesn't contain the modules, even though conceptually the object course would have a list of modules. The thing is that courses can have different numbers of modules, and so the way it's represented in the database is that each unique module, you know, would have name, credits, and assessment, whatever. Typically would have other information, but it has what's called a foreign key. That's why they call it F key. So, and the idea is that this foreign key refers to the value of the course of which it's identified with. So we'll kind of dive into that a little bit more as we kind of go along with this. Okay, see, interacting with this is with a structured query language, and what that is, it's its own language, and as languages go, it's pretty wonky. I mean, it leaves a lot to be desired, and it's really kind of weird, but it's very powerful, and so you just kind of get used to it. There's a lot more than what's here, but these are in my usage. These are pretty much the main ones that I use. The only one that isn't listed here is there's one about joining tables, and we'll talk about it. But the basic ones are, if I want to create a table, you can create a table using a create statement. To insert data, there's a command called insert. Sometimes you want to update data. So if I have, so insert will put a new record or row into a table. Update will take existing rows and maybe change one or more of the values of in the columns. So now when we're kind of, this is kind of the workhorse, select. So with existing data, if I want to take the data and do something with it, and maybe filter it or organize it or even manipulate it a little bit, there's the select statement. So the select statement says, okay, I want to select either a certain number of rows based upon certain criteria, or maybe just select them all and then filter it out as I go. And then the delete statement does, you know, well, if I want to delete a row, then I use the delete statement, or I could delete many rows based upon criteria. So that's, you know, the details of that will come out when we start doing examples. Okay, what is this JDBC thing? So it stands for Java Database Connectivity. They call it JDBC because it's actually based upon an older standard called Open Database Connectivity, or ODBC, and that arose in the 70s and 80s and beyond as databases were first coming out. Each one had their own unique way of dealing with it, and when it started to become a little more standardized, just kind of the way of interacting with it needed to be standardized, and that's where the open database connectivity kind of came in. So why not use that instead of JDBC? Well, the ODBC was very C oriented. It was kind of developed when they figured that C was kind of the main way of interacting with things. But It turned out that wasn't necessarily the case. But ODBC it's everywhere. There are, like, for ODBC bridges to SQLite, to MySQL, to Oracle. I mean, they're kind of everywhere. But if we're in Java, then JDBC is really what's needed. In fact, the first JDBC drivers were only for Windows, and what they did was they connected to a Windows ODBC driver, and basically they didn't do anything, but they made all the heavy lifting be done by this other ODBC thing. It's called a JDBC ODBC bridge. The problem with that is that broke cross-platform. So, and I used that when it was around. It's not around. At some point Java took that capability out when pure Java drivers started to become more ubiquitous. And now pretty much for every database that is reasonable, there is actually an open source pure Java driver, and that's what we'll be using. So what this does is this connects to the database from the program, and you execute queries, update data, etc. But it requires a specific driver to the specific database, because there are now specific calls that have to be made to that database that only that database will understand. So if we're using a MySQL database, as the book examples do, then we need a MySQL driver. We're using SQLite, so we need an SQLite driver. So what's the difference, and why do I prefer SQLite in this context? Well, this is the client server approach, and again, this is analogous to the GitLab thing that we use. And the advantage to that is that the data. So here the database lives on a server, and so you have the database files there. You have a front end, which is the server's API. And then at the client application, so this is the code, and this connector is basically the driver. So in the book, so if you're right, if this would be a MySQL server somewhere, and your application would kind of connect to it through the MySQL driver. Now what they do is, in order to get that running, you basically set up a server on your local machine. So if you've kind of seen that, you connect through the 127.0.0.1 port, which, and so if you're doing server-based things, that's kind of okay. But the SQLite approach is a little simpler. So basically, you have a database file, which is local on your machine, and then your application. This would be the Java program, and then the connector is the SQLite driver in this case. So that's here. What you need is you need to set up the server in order to receive that stuff. Here we don't need a server. All we need is the file. Okay, so what is SQLite? It's open source. It's small. It's fast. It's self-contained. It's almost full-featured. There are a few there are a few things at the nether regions that it doesn't completely support. So full-featured is a little. It's full-featured as far as what we really need, and it's cross-platform. So in other words, that database file that you create can be run on any platform that supports Java, actually. So that's okay. So what we need is a driver, and the book kind of talks about and this is kind of been somewhat overcome by the fact that there's a driver for everything, but they came out that there were like 4 levels of a JDBC driver depending on what it supported, but really a a level 4 driver is pure Java. In other words, there are drivers in which there's some native pieces that you need to use, and those are kind of the lower levels. But these days there's no reason to use any of those. A pure. Why do you want a pure Java driver? Because a pure Java driver, all you need is just a platform, an operating system that supports Java, and since it's pure Java, then end of story. Okay, so the current version, in previous versions we just needed just one jar file, but now we actually need 3 because what they've added in a requirement to have these. This is what they use for logging. It's a fancier way of logging than the basic vanilla stuff that Java has that we've been using. And it's really anyway. It's needed. I've made a couple of videos for how to actually do that, and I'm actually going to do a third because I'm going to do it for you right now about how to configure NetBeans to be able to use these. So let's do that. So what is that going to look like? The first thing we need to do is we need to download the drivers. Now, it actually took a little bit of doing to get these. Why? Because a lot of Java, a lot of the Java projects use something called Maven, which is kind of more of a pain than it's worth for our purposes. So anyway, but if you go to let's see, I think did I link this for the whole thing? What are you going to do? Okay, yeah. So if you just sort of click that link, that will download a zip file that has all of the jar files in them. So so just download that, open it up. Whether you're on Mac or Windows, you can just sort of double click it. On Windows, you'll have to extract it as well. And the video I do there, I do one for Mac and one for Windows. Okay, so and we can just sort of leave them there because now we need to add a third-party library to our NetBeans project. And the way to do that is if I right-click at the top of the project and go all the way down to Properties, I select Libraries, and then here there's a module path, which we're not going to use, but the class path. If you remember way back in the day, I mentioned class path. What class path is, the places where the Java virtual machine looks for classes to load. So there's a little plus sign here, and if we click on that, we say Add Library, and then we want to create a library. Now, if yours doesn't come up with this, it means that back when you created the project, remember there was that little checkbox that I asked you to make sure to check that said to copy the libraries. I don't know if you remember that, but I did. This is why. So if yours doesn't do this, we just need to do it. Does anybody not have this? If you don't, we'll find a way there's a way to fix it. But okay, so we hit create, and you can call it anything you want, but hopefully I'll call it SQLite. Sometimes they put the version in there just to make that clear. Okay, but that's the library, and then it's empty right now, but we want to add add jar, and then, actually here, let's see. Where did I put it? I put it in downloads. And then I want to find, let's make this a list here. Okay, here's the SQLite file. All right, well, here's one, here's the other, and here's the third. And you can either add them one at a time or all like this together. And that says, are you sure? Yes, I'm sure. And then I want to see these three files there. So there's the SLF4J, and then, but the main one is this SQLite JDBC. I say OK, and make sure to add library. If you cancel, it won't be there. And I want to make sure that the SQLite is right there. And once I do that, then I'm done. Now, to check it out, and this is some of the, one of the nice things. In MySQL, as the book talks about, if I want to create a database, I have to say create database. But here, all I need to do is actually connect to a database where the file isn't there. So you remember when I was when we're kind of doing things like reading from a file, if the file's not there, we got to say, okay, do you exist or not? But under the hood, what SQLite does is if I try to connect to a database where the file isn't there, it'll actually create the file in the right format for me. And we'll see that. So let's say I like to call this hello SQLite. You know, again, you always want to do kind of a hello thing that's not going to do a lot of things, but there's a lot of machinery that we need in order to do this. And for some reason, NetBeans is a little dumb about importing the thing. There is a package in the standard Java libraries called java.sql, and that has all of the different interfaces and classes that we can use. Actually, most of them are interfaces that are implemented by the driver. And for some reason, NetBeans is not smart about finding them. So, and I don't know why. So let's create and the okay, so I'm going to create it in this, I like this input directory because I'm going to put it at input because at some point we're going to be kind of reading from it. So rather than, why not output? It can be relative or absolute. And this is just sort of the string. Okay, so now what we need to do is we need to create and it's like a URL, so I'll call it a DB URL, but there's a it's actually JDBC SQLite just like the in the MySQL, it's JDBC MySQL . So, and it's URL-ish in that it, what are the different formats for, we have HTTP : HTTPS : FTP : it's file : etc. So it took that kind of form. It's not really a URL. You can't, access anything on the internet with this. But it's actually better to use the one that they do rather than kind of adding your own string to that. Okay, now what I'm going to do is I want to keep you. So if I try to fix the imports, you notice that, okay, org.sqlite.jdbc prefix. And what that is, if we go and look at that, we see that is JDBC : SQLite . So that's kind of what that is. Okay, so now that's what we do is we can I'm just concatenating, it's just this is the same as plus. So I'm concatenating the identifier exec system out. Okay, what is it complaining about? Why are you? DB URL. And why is it expecting an identifier? Oh, because I was putting it down there. All right, okay, fat fingers. So let's just sort of see what that looks like. So, okay, so this is going to connect to something there, and you can use a relative thing. All right, so now let us connect. Okay, first you establish a connection. And a connection, it's like other things that we've used. In a way, it's things like scanners and file readers and things like that. We need to be mindful about making sure that we close them, whether there's been an exception or not. So, and we get the connection from something called a driver manager. Get connection, and we get the connection from this URL there. So the driver manager is something which is like all the connection is an interface which is provided by the Java in the java.sql package. The driver manager is likewise something which is provided by the SQLite driver. And okay, so let's surround our statement with the try catch and see what we always want to do, because this connection I hope you're seeing a pattern here with how that when we look at system, we're using system resources, we want to make sure that we close them regardless. You see, when we're working in here, if you notice, there's something called an SQL exception that could be thrown. And so when, stuff can go wrong right here, and stuff can go wrong, what could go wrong here? So we could be pointing to a file that we're not allowed to read or write, so there would be an exception thrown there. When there's an exception, though, again, or even if we connect to it, once we start manipulating it, exceptions could be thrown. We need to make sure that connection gets closed, even if there are even if an exception gets thrown. That's what finally does, and that's kind of what we're doing right here. Now, here's the interesting thing, that just in doing this, if I just run this, and all I've done is I've gotten a connection to this, what SQLite will do is it will create that for me. So when I run this, and hopefully it'll run correctly, and it won't. Node suitable driver found. All right, why are you not finding a suitable driver? Got the suitable driver. Oh, I got that, because I got the wrong one. Yeah, see, I was missing one of, let's see, I duplicated. Oh, yeah, so I want to remove that. I want to add the right jar list here. What am I looking for? I'm looking for the SL. What the heck? That is in downloads, SQLite files. I mean, there it is. What did I have? I had the, okay, I need these two, not this one. Yeah, that's right. All right, now it should work. Okay, so notice that, okay, it ran successfully, but look at what it did. If I go to input, I see that this is what was created, this hello database. So, so now what can we do with this? We can create a table. How do we create a table? Well, let's see, maybe I should go back to this. Okay, so we've successfully done that, at least I've successfully done that. Now here's a sample database design. This is actually one of the standard kind of sample databases out there. What it is it's a, they're selling these tracks, and then as you can see, we have different artists, and each album has a certain artist associated with it. Each track is associated with an album, and then we can create playlists from these tracks. So this is the one-to-many here. So a playlist can consist of a number of different tracks, and each track can be in, so a playlist will have many tracks. Each track could be on many playlists. So this is that intermediate table, and this is basically how you do it. So what you do is you create this intermediate one, which has a playlist ID and a track ID. So those two together will form a unique key. So in other words, for any given playlist, there will be exactly one copy of that particular track in there. And likewise, for any track, it could be on multiple playlists, because if I want to create a new playlist and then add a track to it, then I would instantiate one of the, I would create one of these guys, and you see how that. And then it looks like they're selling it. They have employees that has supervisors, and then customers, and then invoices, and as you can see, it's fairly complex, but I'm mainly kind of concerned with this upper part here. So we have the media type and the genre. So it's like, and they have different genres from classical to rock to whatever. So this is, and this database is something we're going to be playing with. Okay, so we've seen the connection. That's the interface between the program and the database. We've seen the driver manager, which we use just in that one place to establish a connection. And then the other two mainstays are statement and result set. So a statement is what we create a statement from the connection, and we use that to execute queries and updates. If we do a query, that will typically return one of these result set things. And that's an iterator-like thing where we can use to step through. So here's what we kind of have done already. So that we got the get connection from there. Now a statement, which we haven't quite done yet, as we can execute a query such as select. Here's a select one, which will return a result set that we'll be dealing with, or an update. So here's how we're using an insert, and we would typically use an update to also do do like a delete type of thing, or an update command. Okay, so where are we here? So here's a typical kind of usage of this. So we'd execute a query, and the contents of this would be, say, select something from something, and hopefully say one of the column names would be called name, and then the result set object has one of these next things. So when I say next, just like the iterators that we've been using, it advances to the next and is kind of pointing to the next record. And in that record, what we can do is we can get the string. We can get a string by saying the column name, or we can get it by column number, which is not totally recommended, but there's actually kind of a way of doing that. What we have to be careful about is they actually use one-based indexing, which makes more sense in a global sense, but if we're at a programmer, everything is zero-based indexing. So that's okay. So let me just to see a little. See, do I have time to? All right. So let's do a statement. Here's how we do it. We get a connection, we get statement, or create statement, create. And see, the idea there is that, I mean, a statement needs to understand what it's connecting to. And so it makes sense to get that from a connection, because if we just have a statement that's kind of just out there, and we say, okay, select something, then the natural answer is, or question is, okay, what do you want me to select it from? So let's see if I can. Okay, so as you see, there are lots of different things here. And then there are fancy things using prepared statements that we can do. Let's create a table. So create table. What are we going to call the table? And then what we need to do is, okay. Let's see. Primary key. And let's see, name, and then they like sort of varchars. I think it was, oops, that should work. Let's see if that works. Okay. Okay, here's the insert statement. Insert into values, and let's give it 1, and okay. Oh yeah, here's where you have to be a little careful. Unlike Java, SQL kind of it will use either a double quote or a single quote. So here we have to put it within within the string. I think single quote should work. Why are you complaining here? Oops. Oops, that didn't like that. Oops, yeah. So, oops, it says it was trying to create a table that already existed. So now I need to actually just kind of do it there. And so now, let's see if now let's sort of just select name from first table. Okay, that gives me a result set, and I say while rs next. If there were more names. I get a string from the name. And so what I'm looking, it should print George for me. And then if I, oh, so let's add a second one. Okay, so now I've added those two to that. So, okay, so I've had, so connection, getting the statement, creating the table used from the statement, and I think, now this is a non-standard thing. Let me, I think, okay, now in some forms of SQL this will work. And it, constraint failed, unique, blah, blah, blah. Oh, it's, so I'm, okay, yeah. Okay, so if not exists is supported by this. Not all databases do. Okay, so I'm saying only create the table if it doesn't exist. And now I'm kind of inserting them, as you can see they're all there. And all right, so now there's more useful information in the book, and we will, now starting tomorrow, what we're going to do is we're going to take a look at this example database, which is actually available on the in the handouts folder, and we'll keep going from there.